Welcome to an Achieving Science video. This video is going to look at the electrolysis of brine. So, first of all, let us begin by a recap on what happens during electrolysis. And if we begin by looking at the diagram of an electrolysis cell, we can see what's happening. We can see that we have two electrodes, one named the anode and one named the cathode, and these are going to be important. So, ionic compounds like sodium chloride can be dissolved. When they dissolve, they form solutions that conduct electricity. They conduct electricity because there are negative charges that are able to move throughout the solution. So, at the positive of the electrode, which is named the anode, this is where negative ions lose electrons. Remember that electrons are negatively charged. At the negative electrode, this is called the cathode. This is where positive ions gain electrons, again remembering that electrons are negatively charged. And then finally, the final part is the electrolyte. This is the liquid or solution that is able to conduct electricity. So what is in the solution and what is happening when sodium chloride undergoes electrolysis? Well, in the electrolysis cell, the electrolyte contains sodium chloride solution. So therefore this means that the electrolyte contains sodium ions, which are positively charged, chloride ions that are negatively charged ions, plus there is water. Water, being H2O, can divide up into hydrogen ions, which are positive ions, and hydroxide ions, which are negative ions. Therefore, this now gives us the question whether or what is formed at which electrode. Let us begin then by looking at one electrode. Well, if we begin, we can find that there are actually two positive ions. There are hydrogen ions and sodium ions within the electrolyte. Both of these ions are able to be attracted to the cathode, as it is negatively charged. The question is, which is more reactive then, hydrogen or sodium? Sodium is more reactive than hydrogen, and therefore the sodium stays in solution. This means that hydrogen gas is therefore formed at the cathode. Now let's have a look at the anode. Well, at the anode, again, there are two possibilities of what could be formed, because there are two negative ions in the electrolyte. There is the hydroxide ions and the chloride ions. Both could be attracted to the anode, as it is positively charged. Again, ask the question, well, which is more reactive? Hydroxide ions are more reactive, and therefore they stay in solution, along with the sodium ions. Chloride ions are therefore attracted to the ion, forming chlorine gas. Now these reactions can be summarized, and they can be written as half equations. Let's have a look at these in a bit more closer detail. So at the cathode, remember this is the negative electrode. This is where the positive ions of hydrogen are attracted. So two positive hydrogen ions gain two electrons to form hydrogen gas, H2. At the anode, on the other hand, the positive electrode, two chlorine ions are attracted, which lose electrons to form chlorine gas. Remaining in solution then is sodium hydroxide, NaOH. Now we can look at these equations in a bit more detail. We can use the term oil rig to remember this, where oxidation is loss of electrons and reduction is gain. And now using this, we can determine what is happening at the cathode and the anode. Well, at the cathode, this is an example of a reduction reaction, as the hydrogen ions have gained electrons. Whereas at the anode, this is an example of an oxidation reaction, as the chloride ions have lost electrons.